This illustration deals with grounded systems permitted to be connected on the supply side of the disconnect. Now notice we would review 230.82 when we provide any kind of tap on the supply side of the service. But to review grounding and et cetera on the supply side, then notice we'd go to 250.130A and we'd go to 250.142A, and you get a better understanding why these changes took place. So the purpose of change is to provide a new section. And this new section has been added really to clarify the requirements for grounding systems permitted to be connected on the supply side of the disconnect. Not all equipment grounding to the utility is considered a service, such as a parallel power production equipment, but should be grounded and bonded with the same requirements. And some instances or in some types of examples, such as solar installations, parallel power production equipment is connected in parallel with a service, and in some cases connected directly to the utility solely for the power production to the utility, and no service equipment is in parallel. So the addition of 250.25 and pointing to the appropriate parts again, say of 250.24, ensures that supply side equipment is connected to a grounding electrode system that has an effective ground fault, whether it is grounded service conductor or the supply side bonding jumper, and is bonded with the more requirements of 250.92 and 250.102C that we're talking about here. So anything you connect to the supply side, you must look at 230.82 and look at 250.142A, and you get a good feel for that. So the grounding electrode conductor, if you look at it from the panel to the left, because we have a grounded system, then notice it's used to connect the grounded conductor coming in, as you see in the panel, connect all your equipment grounds and neutrals to that bar, and it is connected into the earth ground 250.50, 250.52, and 250.53. So the call out basically says, used to connect equipment grounds, service equipment enclosures, and where the service ground is grounded, the grounded service conductor to the grounding electrode conductors or electrodes formed together to create a grounding electrode system in accordance where to 250.24D that we would look at. Then notice that grounded conductor in the panel board to the left. Notice it talks about grounded conductor or neutral in parentheses. You have to look at both table 250.102C1 and 220.61 and take the larger, either sizing it for the grounded conductor to carry fault current and then to take care of your neutral current. And then notice all your equipment grounds is sized by 250.122. Now, the panel board transformer to the left is ungrounded, and we just pull in a chassis ground. But the chassis ground has to be installed now by 250.102C1 by this section. And again, it's referring you to 250.24 to obtain this information. The meter marking and everything's in 230.66, and it's not a considered service. But to the right here, that transformer is ungrounded. So we're looking at maybe 250.121, or we're looking at Article 90 in the National Electrical Safety Code. Now, looking at the note, the equipment grounding conductors and metal conduit and cables, plus the metal or such wiring methods shall be connected to earth ground at the service equipment grounding points. So again, that chassis ground coming in is connected to earth ground at the service equipment, but not at the transformer, because we're running an ungrounded system. And then, of course, again, when you run an ungrounded system, you have to check both with the authority having jurisdiction plus the utility company to see what their requirements might be to do such. So we would look at Table 250.102C1 for supply side grounding. But load side grounding, Table 250.122, and just basically speaking, supply side grounding, there's no overcurrent device ahead of your conductors. Load side grounding, there is. Verified where? 250.142A1 and A2. So good luck with this section, and I think you'll be fine with it. Thank you.